Hello and welcome back to Element 14 Presents. I'm Andy, and in this episode, we're going to build an augmented reality application that teaches basic circuit building. Augmented reality, or AR, combines the real world with computer-generated objects or elements. You may have seen a simplified version of this if you've ever played games like Pokemon Go on your phone. More advanced AR solutions involve headsets, like the HoloLens 2, but they're relatively expensive. So I'm going to use the Quest 2 headset for this project instead. This was really designed to be used for virtual reality, but if we use what's called a pass-through feature, we should be able to make an AR application that can teach someone how to build a simple electronic circuit. It's a little hard to explain, so let me show you what I mean. Here I've got something called snap circuits. Now this is a learning kit that my kids borrowed from the local library, and it's kind of like a breadboard. As you can see, the parts just snap into place, and there's a variety of different things that we can combine to make a circuit. Now there's a reason that we're using these, which I'll explain in a minute. So now I'm going to put the headset on and show you a simulation of what the application will look like using the pass-through feature. You'll notice that everything is black and white and kind of grainy and fuzzy. And you have to remember that this is a VR headset, and the cameras that are in the front were originally only designed for tracking. So head tracking and hand tracking, controller tracking, which I don't have the controllers right now. But now we're using the cameras to see our environment, which is a relatively new feature in the API. On the table is a translucent image, a kind of hologram, and it looks exactly like one of the snap circuit components. The other virtual object here is a button that you can press. So what we do is we place the real part where the virtual part is, and then we press the button to go to the next step. And if we repeat this enough times, we should get a fully working circuit. Now that was just a video effect. It wasn't really the pass-through mode of the Quest, but hopefully it gives you an idea of what we're trying to accomplish. Now you might be wondering why I use snap circuits instead of actual breadboards and, just regular components. For example, why would I use this chunky plastic module rather than just a regular resistor? And the answer has to do with image quality. The Quest 2 is a very capable and affordable headset, but it just wasn't designed for augmented reality. So the compromise is that the images from the tracking cameras is low resolution. We have to be able to clearly see and differentiate between the different components in order for this to work. Now in the future, when VR headsets have color high resolution cameras, this won't be so much of a problem, but for now, this is what we have. Also, rather than use actual snap circuits, I'm going to create my own 3D printed parts. And there's a couple reasons for this. One is that we need to create 3D models of all the parts anyway to use in the AR application, and they need to match the dimensions of the real-world parts. So we could create a single model of, say, a slide switch and 3D print it and use that same model in the AR app. Another benefit is that I can share those models with all of you in case you want to try it yourself. So I've made a quick sketch of the parts we'll need, and you'll recognize these as being very similar to the ones that I showed in the demo. We do have an LED here rather than an incandescent bulb. That's the main difference. Down here we've got a switch, and then we have a 1K resistor over here, and we need a voltage source, so a couple of AA batteries in series will give us roughly 3 volts, which is appropriate for our LED. Next we have to decide what we're going to use for snaps. So if you look here, these are pretty similar to like button snaps that you'd see on clothes. I don't have any of these handy, but what I did find were these. These go by various names. You might see them called axle nuts or cap nuts or something along those lines. They're used to secure a wheel to an axle, but I figured out that you can fit a couple of 6mm neodymium magnets. Anyway, I discovered that 2 magnets fit inside there perfectly, and my hope is that we can use the nuts as electrical contacts and the magnets inside will join the parts together instead of the snaps. Could work. If you've seen my videos before, you probably know that I prefer Blender for modeling and that my designs are pretty simple. I tend to start with basic primitives and I use a lot of Boolean modifiers, which I'm sure is not the best technique, but it gets the job done. I'm going with a basic rectangular shape, and then I carve out the middle so that I can add wires. The shell for each component will actually be 2 parts, which snap together, so I have to get the tolerances just right. This one's going to be a switch with 3 pins, and so we've got 3 holes, and of course we've got these cylindrical areas and the holes for our axle nuts. Let's print this and see how we did. So we take a couple of nuts and put them back to back like this, and when we snap the top and bottom together, it'll create a contact point on both sides. We put magnets in here, oriented with the correct polarity. It will attract the contacts from the other components. If you're not sure about the polarity of your magnets, there are apps you can get on your phone. I think this is a really cool use of the magnetometer that's normally used as a digital compass. I'm pretty sure this is zinc-plated steel, and I found that I have to sand the plating off before it can be soldered. I also discovered that sanding them helps a lot with electrical conductivity. We want to solder the wires before adding the magnets because too much heat can affect the magnets. Now, I'm not going to show you how I designed and built all of these because the process is basically the same for each one. I'll upload the STL files to the Element 14 community for anyone who's interested. But suffice it to say, there was a lot of iteration and tweaking and a few mistakes along the way. The final parts work pretty well, and now that they're done, we can focus on the software.
Hi, I'm David from Element 14's The Electronics Inside. Join me as I tear down toys, tools, appliances, modern, vintage, classics, and even some new releases just to find out what's inside.
We're going to build our application in a game engine called Unity, and what I've discovered is it takes a lot of configuration. It's a very detailed process. So I'm going to walk you through each individual step. Before you start, you're going to want to install Unity Hub and the latest LTS version of Unity. LTS stands for long-term support. And if you go into Add Modules, you're going to want to have Android build support selected because the Quest is an Android-based device and everything under there installed as well. You're going to want a code editor, and I use Visual Studio Community 2019 because it has good integration with Unity. We're going to build the simplest hand tracking and pass-through application that we can. So it's just going to be a simple cube floating in the room that you can grab and move around with your hand. And once we get that working, then we can move on to the next step. So we're going to create a new 3D core project, and we're going to call it AR Cube. The first thing we're going to do in our new scene is delete the main camera and change the directional light color to white. Then we're going to go to Edit, Project Settings, XR Plugin Management, and Install XR Plugin Management. So Oculus checked here, here, and here. Then you want to go to developer.oculus.com and download the Oculus Integration SDK. After the package is done downloading, you can open it and then just say Import. When prompted for the newer OVR plugin, click Yes, and then use OpenXR, and then say OK, and restart. Okay, lots of questions. Upgrade, restart, save. Okay. Since we imported all that stuff, we've got all these assets. So we're going to search for an asset over here. We're going to look for OVR camera rig, and we're going to take the OVR camera rig and drop it right. There we go. Now in the inspector, we're going to go down to Quest Features, and we're going to say Pass-Through Capability Enabled, and also Enable Pass-Through. Then we want to go to Tracking and say Tracking Origin Type Floor Level. And Color Gamut, instead of Rift CV1, should be Unmanaged. For hand tracking support, instead of controllers only, we want controllers and hands. And we're almost done setting up Pass-Through, but there's one more thing we need to do. We need to add a component, OVR Pass-Through Layer. And for the pass-through layer placement, we want underlay. Next, you want to expand the OVR camera rig in the hierarchy, expand tracking space, and you're going to see left eye anchor, center eye anchor, and right eye anchor. And for each of these, we want to change the background color to black. The next thing we want to do is get rid of the skybox. The skybox is normally the background for our environment, but if we actually render that skybox and we're trying to use pass-through, it will hide the pass-through, which is something we don't want. So we want to go to Window, Rendering, Lighting, here in Environment, There's a skybox material. Where is it? Here it is. What happens if I just hit delete? Okay, delete sets it to none. All right, so next we're gonna go to our build settings because right now we're targeting Windows. So we're gonna go to build settings, set to Android, and then we're gonna switch platform. You gotta click the switch platform button. Then we can go into the player settings. So first thing we need to do is change color space to linear. Then we want to deselect Auto Graphics API, and we want to remove Vulkan from the graphics APIs. Under identification, we check the override default package name and get rid of that warning there. And we want to set the minimum API level to Android 10. So you want to change scripting backend to IL2 CPP. That's very important. And this is also very important. ARM64 is the only target architecture. So get rid of ARM v7. Over here, we're going to search for OVR hand prefab. And we're going to drag one into left-hand anchor and one into right-hand anchor. So the hand type, skeleton type, and mesh type are all hand left for both the left and right hands. And for the right hand, we want to switch hand type to hand right. Then we want skeleton type to hand right and mesh type to hand right. All right, we're finally ready to add our cube to our scene. This is a cube that we're going to be able to grab with our hands and manipulate. So we're going to say 3D object, cube. Okay, we've got our cube. Next thing we want to do is add an OVR grabbable script to the cube. So we're going to click on this cube, add component, and we're going to have a OVR grabbable. Click that guy, and the grab point is going to be, and grab the cube, drop it in there, cube, box collider. That's what we want. Then we want to add a rigid body. This enables physics. Then we're going to create a new material, and I'll just call it cube material. I'm going to set rendering mode to fade. We're going to set alpha to 190. And we're going to drag our cube material onto add component here, and it changes the material of the cube to the cube material. And you can actually see how it's sort of a little bit see-through. Now we're going to add rigid bodies and sphere colliders to the OVR hand prefabs, and this will allow us to have physics interactions with our hands. If we didn't do this, then our hands would have no effect on the objects in the scene. So we're going to go add a rigid body, and we're going to add one to prefab right. Then we're also going to add a sphere collider. Now for each rigid body, we're going to turn off gravity and check is kinematic. And then finally, we're going to set the radius of the sphere collider to 0.2. All right, we're getting near the end now. We need to create a new script. We're going to call it hand tracking grabber. And what this does is every frame, it checks to see if we're pinching our fingers to within a certain threshold, and if we are, then we begin grabbing the object. So this is enabling the grabbing functionality through code. Now that we've got our script, we want to add it to both of our OVR hand prefabs. Hand tracking grabber. And we want to check parent held object on each of them. And then for the grip transform, we want to take the corresponding prefab and drag it on. So for the OVR hand prefab left, hand tracking grabber grip transform, it's OVR hand prefab left transform. And finally, the last thing we want to do for each one of these is make sure the OVR skeleton renderer script is disabled and the mesh renderer is also disabled. Okay, that was a lot, and now we get to test it. So I'm going to use the Oculus link cable because that way when I build and run the application, it will automatically upload to the Quest. But rather than try and show it to you in this confined space, I'm going to upload to the Quest first, and then move to a more open area where I'm untethered, and then I can demonstrate it properly. All right, it's time to try it. All right, here we go, moment of truth. What? No. All right, I'm sure this isn't coming through in the 2D image very well, but this is so surreal. It really looks like it's in the room. That is so weird. I don't even, I'm not even sure exactly how to describe this. All right, now it's time for something more interesting. Let's turn this into our Circuit Builder app. All right, so all I did to create our new project was to copy the AR Cube folder and rename it AR Circuit Builder. So now what we're gonna do is we're gonna go into File, Build Settings, Player Settings, and over here in the product name, we're also gonna change that to AR Circuit Builder. And then we're gonna go down to Override Default Package Name, and it still says AR Cube, so we're gonna uncheck that, and then we're going to recheck it, and it's going to refresh that value. Next, we're going to change our hand tracking grabber script to only work with the left hand. And the reason is that we're going to use our cube as an alignment tool to align our virtual world with the real world. Next, we want to go into our OVR hand prefabs and go into the sphere collider radius and make it just a little bit smaller. We're going to go from 0.2 to 0.15. We're going to rename our cube material translucent gray, and then we're going to say Control D to duplicate, and we're going to rename the copy translucent green. Now we're going to duplicate the cube itself, and this is the button that we're going to use to move to the next step in our circuit builder. We're going to check is trigger on the box collider, and we're going to check is kinematic on the rigid body. Now we're going to remove the OVR grabbable script, and we're going to add a new script, and we're going to call that one hand tracking collision. So what this collision script does is when we press the button, it changes the material of the button from gray to green. The other thing we're doing is we're manipulating this list of parts, the batteries, resistor, LED, and switch, which haven't been added yet. And then every time we press the button, we activate or make visible the next component. Now we want to add the new script to the next button, and we can just drag the script over to add component. We forgot to actually change the color of the green material to green. So change the color to green. There we go. Drag the gray material to the gray material property and the green material to the green material property. Now we're going to remove the hand tracking grabber script from the OVR hand prefab right. We want to clear that because we're not going to use our right hand for grabbing things. Now it occurs to me that it would probably make more sense if our next button wasn't a cube. It would probably make more sense as a cylinder. So let's change the cube to a cylinder. That makes more sense. Now we'll create a folder for our Blender models. We'll just call it models. And we'll just drag each of the files individually into the models folder to import them. We'll just add those one by one to the scene just by dragging them. And then we will arrange them. And you can just individually manipulate each one until you're happy with where they are. You can see I paused the video and took some time to arrange the components exactly the way I wanted them. And then I took all the components and the next button and I added them as children to the cube. So now when we manipulate the cube, it will also move the button and the components so I can align everything at once using this cube manipulator object. Are you ready? Let's take a look. All right, here goes something. This is it. This is the final test. Well, hopefully the final test. Whoop, okay, they're floating in midair. Not to worry. Okay, so that's my calibration cube. Ooh, it's very sensitive. All right, I'm gonna try and get it so it looks like they're sitting on the table surface. All right, ready to go? What happens when we push the button? What? Oh my gosh. Okay, this is crazy. Okay, the resistor goes there. Yeah, resistor goes there. All right, and one more component. What do we got? The switch. That is nuts. Well, that is an MVP right there, minimum viable product. It works, it technically works. Nice. That's all we have for today. Have you ever created a VR or AR application relating to electronics? Let us know at the Element 14 community, and we'll see you next time.